Hi everyone. So I'm going to talk about equally likely probabilities. In this case, we're going to talk about those probabilities that are replacement, right? Because probabilities, you can replace the item or you can do no replacement. And for those who know what that means, is that I'm not going to do probabilities that have no replacement. Everything is being replaced. So when you do one probability, you put the item back. In this case, the bag. All right, that's one thing. The other thing also is that you need to be aware that, the whole idea of these shapes is, first of all, they have different properties. A star and a circle are not the same. They have different properties. They're different shapes. And so different properties, they're not the same, right? The whole idea is that you can identify these items by their shape. Another thing that they also have is a number, right? Now, the star and the circle, they don't have anything in common because they're a star and a circle. But they do have something in common because they have a certain property that the number is what? That's right, odd. The numbers they have, they're odd, so they do have something in common. So properties describes these items through properties that they have. So you can have another star, right? Which you do in this case. You have another star, but this star, it has a 4. Now, they have the similar property of being stars, but the values here are different. One is odd and the other one is even. So the only thing that they have in common is the shape. Now, you could say that 4 and 5 are consecutive values. Is that a property? Yes, that is a property, that they are consecutive values. So you have to think a little bit more. Here's another one too. 5 and 4. This one is prime. This one is not. 4 is not. So it goes beyond statistics. It goes beyond to describing numbers in a certain way as well. So I don't want you to get into the trap of thinking that just because the star has a 5, it means there's 5 of these stars. No, it does not mean that. Or else you would draw these in here. So the values inside the items is, again, another property. Okay. And if you didn't get that, just rewind the video and listen to it again. And then see if you kind of get it as I'm doing the problems. Okay, so the first one says, what's the probability that you choose a star in the bag? Yeah, you go in the bag. What's the probability of choosing a star? Now, of course, the bag, you can't see inside the bag. You just put your hand in there, and then you choose an item. Sure, you can choose a star. You can choose a triangle or a circle or a square. But how likely is it, by randomness, that you're going to choose a star? Well, how many items do I have? That's a good question. Let's see, let's count those. 1, 2, 3, 4, 5, 6, 7, 8. There's 8. So that means I have 8 items, right? And then, how many are stars? 1, 2 of them. There's 2 of them. 2 of them that are stars out of 8. and thus I get 1 over 4. Make sure you reduce. Okay, the next thing. What's the probability of a square and a star at the same time? Sometimes the and is represented as an intersect, right? What's the probability of a star? What's the probability of a square and a star at the same time? Usually you don't say that piece at the same time. So you're going inside the bag. You're going to choose an item, one item. One item. Yes, it says two things here. But remember, these are properties of the things you're choosing. And that's something that really sometimes is not explained clearly. This probability is choosing what they call an event. The event is a certain property of what you are observing. So when you put your hand in there, the property that you're trying to choose in the bag is a square and a star at the same time. One item. And there isn't, out of 8, there isn't a star inside of a box. Or you have a star, right? That's horrible. Star in a box. You don't have anything that looks like that. So, because you don't have anything that looks like that, it's going to be 0. And thus, sometimes it's called the empty set. You can put a slash on there. It's not 8 over 0 because that's undefined. So don't write it that way because it's not true. Okay, the next one is, a little tricky, but there's clues when you do this problem. There's this thing that's called a pipe. Okay, pipe. The pipe is, if you look at a keyboard, right, on the right of the keyboard, there's a backslash and then there's the pipe. Pipe is used a lot in computer science. This pipe is called given, or sometimes given that. What it means is that you're looking for something. You're looking for something that's even. Given that the items are squares. Now, this piece right here, given that the items are squares, that gives you additional information that you didn't have before. You see, this problem, number 3, starts off like this. Starts off as a bag. And it says, hey, look for even problems, or not even problems. Look for even properties, right? Like 4 is even, so is 14 and 6, right? And 12. And you might think, okay, I found them out of 8. I should be done. But no, it's asking you, given that the bag only has squares. The bag only has squares. And how many squares do you have? Well, you only have 2 squares in the bag, right? Again, this pipe, this symbol tells you on the right of the symbol what you have in the bag. What property do you have in the bag? So the bag only has these 2 items because there's only 2 squares. One of them is a 12 and the other one's a 15. And out of these 2, which one's even? Is there one that's even? Yes, there's only one of them, and that's the 12. And that's how you do these problems. You can think of these things are called conditional statements. When you have a conditional statement like this, and you have this pipe, think of the pipe as you're cutting the bag, right? In this case, you are cutting the bag and you're only leaving, in this case, the squares, right? Because it's giving you new information. It's a conditional statement in that it's giving you new information so that you can figure out the probabilities. Conditional statements are very important because they give you it narrows your probability. It narrows your probability of finding what you're looking for. Okay, let's keep going. Let's do the next one. Next one says, again, we have a conditional statement. What's the probability of choosing a star given that we have odd values, right? So the property of a star, given that the items are odd. So in our new bag, right, because this conditional statement will give us new information, we have an odd. Which ones are odd? For our new bag, well, there's a star. That's odd. What else? There is a circle. That's odd. Right? And another circle. That's odd. And then there's a square. That's odd. Right? 5 is odd. 6 is not, because you can divide it by 2. 3 is odd, but not 14, because 2 goes into 14. 9 is odd. 4 is not, because 2 goes into 4. 12 is not, because 2 goes into 12. And 15 is odd. So 12 is even. 15 is odd. So there's 4 of them. 4 of these items. And again, this gives you a conditional statement. Think of this as cutting the bag, right? And the bag now has 4 items. Again, you can't see inside the bag. But what's the probability of choosing a star? Well, there's only 1 star in there. 1 star that's odd out of 4 odd items. There's 1 star that's odd out of 4 items that are odd altogether. That's not too bad, is it? And then the next one is choosing a circle. What's the probability of choosing a circle given that they're all squares? Right? So you have a new bag with all squares, right? And you're going to choose a circle. How likely is it that you're going to choose a circle inside of a bag that only have squares? That's right, 0. No chance. 0 probabilities, right? There's no way you'll be able to find a circle inside of a bag. You're not going to find a circle inside the bag because you're told that all of the items inside the bag are squares. How do you know all the items are squares? Because there's a conditional statement that tells you before you start that the bag has been cut. And inside the bag, there's only squares. Okay. I hope that's been helpful. Now you can do some of these probabilities that have a little bit of a challenge, but the idea here is that the properties do matter in terms of what you're looking for.